Professor Elena Mercer stood frozen before the holographic display, her coffee gone cold in her trembling hand. The JWST data flickered in the dimly lit observatory, a three-dimensional map of distant galaxies, most of them spinning clockwise like countless luminous pinwheels in the void. "This can't be right," she whispered, but the numbers didn't lie. 66%. Nearly two-thirds of all observed galaxies rotating in the same direction. The statistical improbability was astronomical, quite literally. Random cosmic formation should produce an even split, yet here was evidence staring her in the face, challenging everything she thought she knew about the universe. Her colleague, Dr. James Way, entered with a stack of papers. "You're still here? It's past midnight." "James," she said without turning, "what if we're looking at this all wrong? What if the universe isn't just expanding outward from a Big Bang, but growing inward from something else?" "What are you saying?" Elena gestured to the hologram. "What if we're inside a black hole?" Think of a black hole like the womb in pregnancy. Just as a womb nurtures and grows an unborn child until it's ready to come out, a black hole could incubate its own baby universe until it's ready to emerge. When a massive star burns up its fuel, it collapses and forms a black hole. The matter within gets denser and denser until it reaches a point called the singularity. According to some theories, instead of the matter being crushed to an infinitely small point, it could bounce back. This bounce could create a new universe, much like a baby being born from a womb. Consider the formation of a soap bubble. From outside, we see a thin spherical film with a distinct boundary. But inside that boundary exists a complete miniature world with its own atmosphere and light reflections. Similarly, a black hole might appear as a boundary from our perspective while containing an entire universe within. If black holes can give birth to baby universes, it means the universe is not a closed system, but part of a vast network of interconnected universes. The matter that falls into a black hole, stars, planets, even light itself, appears to vanish from our universe. But that matter and energy don't simply cease to exist. Conservation of energy, one of physics' most fundamental principles, suggests they must go somewhere. In the cosmic womb theory, they become the building blocks of a new universe, recycled into fresh cosmic material. Picture a composting machine. You throw in your kitchen waste, vegetable scraps, coffee grounds, etc. And over time, the waste is broken down into rich soil that's used to grow new plants. In this analogy, the black hole would be the composting machine, with matter being recycled to form new universes. The idea here is that instead of a one-time event like the Big Bang, our universe could experience a cycle of collapse and rebirth. When matter falls into a black hole, it appears to collapse to an infinitely small point, a singularity. Quantum mechanics suggests that the rules break down at such scales, potentially allowing the universe to bounce back instead of collapsing infinitely. This bounce could resemble a Big Bang event, starting a new universe. Imagine bouncing a ball. Each time it hits the ground, it compresses and then rebounds. If the universe could bounce back after collapsing, it would be like that ball returning to the air, starting a new cycle of expansion. We see comparable dynamics in supernova explosions. A massive star collapses under its own gravity until the core becomes so dense that it rebounds, causing the spectacular explosion we observe. The black hole bounce would operate on a vastly larger scale, but follow similar principles. If we're right, then each black hole in our universe could be creating new universes with slightly different properties. That's cosmic natural selection. This concept of cosmic natural selection draws parallels to biological evolution on Earth. Just as environmental pressures select for traits that help organisms survive and reproduce, the physical conditions of parent black holes might select for universe properties that lead to the formation of more black holes. Consider how different tree species evolve distinct characteristics based on their environments. Deciduous trees shedding leaves to conserve energy in winter, while evergreens maintain their foliage year-round. Similarly, universes might develop different physical constants based on their parent conditions. In our own universe, the values of fundamental constants like the strength of gravity, the speed of light, and the charge of an electron seem precisely calibrated to allow for complex structures including stars, planets, and eventually life. If slightly different, stars might never form, or matter might never coalesce. This fine-tuning, rather than being designed or coincidental, could be the result of cosmic evolution across generations of universes. Elena's team gathered around the quantum simulator, the machine humming softly as it processed the most ambitious calculation of their careers. They were attempting to model the death of a parent black hole and its potential effect on a baby universe within. "The simulation is reaching completion," announced Dr. Lakshmi Patel, their quantum physics specialist. "Rendering final state now." The holographic display flickered and then stabilized, showing a three-dimensional representation of space-time. As the simulated black hole evaporated, the model showed ripples propagating through the fabric of the baby universe. Subtle at first, then increasingly violent. "My God," whispered James, "the constants are shifting." They watched in horrified fascination as the simulation showed fundamental forces within the baby universe beginning to fluctuate. Gravity weakened. The strong nuclear force strengthened. Matter began behaving erratically. "If this is accurate," Elena said, her voice barely audible, "and if our universe is indeed inside a black hole, then we need to know if our parent black hole is stable." The room fell silent as the simulation reached its conclusion. The baby universe hadn't been destroyed. It had transformed into something unrecognizable, with new physical laws emerging from the chaos. Lakshmi pointed to a reading on her tablet. "Elena, we're detecting unusual neutrino patterns from the galactic center. They started 3 days ago, and they're intensifying." Elena looked from the tablet to the simulation and back again, a chill running down her spine. "What if it's already happening?" she whispered. "What if, beyond the boundaries of our observable universe, the very foundations of reality were already beginning to change?"